So the command line interface that we've been using is something known as the bash shell. It's often referred to as the bash. Sorry, it's not often referred to. The bash refers to it's an abbreviation for the born again shell. Computer scientists and lots of scientists love puns, so we're always itching for a nice one. But it's one of the most commonly used Linux shells. So there's C shell, there's a couple other shells, but bash is the one that's most commonly used. When we use bash shells, in addition to programs and commands like cd and make mkdr and rm, there are also a lot of symbols that have specific meaning. And we refer to these symbols as operators. And operators tell the kernel to perform specific functions like math or relational or logical functions. In other words, they're operators. They do stuff. And so some examples include the asterisk, the less than, the greater sign, two greater signs or two less than signs, the bar, all different kinds of symbols. And one of the first ones we're going to talk about is the wildcard. So the wildcard or the asterisk can mean anything. And this is especially important for when we think about how we want to match characters or how we want to sort through different types of characters. So to show you an example of how this kind of thing could work, let's say I'm looking at this directory, right? And in this directory, there are a bunch of different types of files, right? So we have these .fastq files, we have a .txt file, we have a .fasta file, we have a .batch, and a .files_important file. Let's say I wanted to do something with, I just wanted to look and see, well, what are the fastq files I have in this directory? To do that, I just want to look at the fastq files. I could say ls, and then I can use the wildcard fastq, right? If I now hit enter, one of the things that you'll notice is that it's only going to list the things that ended in a fastq. So in this case, the wildcard is anything before the fastq, but anything that ends in fastq. So this is a great way to find different types of files. So say I wanted to find anything that ended in a .txt, I could find all my text files. I could find all my FASTA files, right? I can find all the certain types of files. And it doesn't just have to be one wildcard. You can use multiple wildcards. So notice that for all of these FASTQ files, there is an R1 file and an R2 file. These are paired sequences. So these files go together. This file always goes with this file. But maybe for some reason I only want to look at R1 files. Didn't want to look at R2 files. So if I want to list them all, I can say wildcard R1 followed by wildcard fastq. That means anything that has an R, it's going to list anything that has some stuff in front of it, an R1, some stuff between it, and a fastq. And there could be nothing between these things, but it's got to have an R1 in it, and then it's got to end in a fastq. So if I hit enter now, you'll see that I'm able to select just the things that have R1 and end in fastq. So to try out some examples, I'm going to ask you guys to try out, I'm going to show you how to do, ask you to do these exercises. I'm not going to show you the answers, but I'll go over them in class. But you should all be able to understand how to accomplish each of these tasks. So you're going to use the list command. You're going to go into the bin directory, right? And there's a whole bunch of stuff in this bin directory. And I want you to use the wildcard and the list command to identify answers to these four things. So one thing I haven't shown you is I haven't shown you how to access historical commands. If you type the word history, it's going to list all the commands that you've done in the past. And if I wanted to run one of these commands, say I wanted to run this list command, or I wanted to run this list command here, right? I want to list all the FASTQ files. There actually aren't going to be any FASTQ files. Let's say I wanted to run just the list command here. Notice they all have a number next to them. If I want to run that command, all I have to do is use exclamation point, the number, and then it's going to run that command. So it's going to run that list command. So it's a nice little thing. You know, for a short command like list, it's not really that important, but let's say I had a nice long command and I wanted to repeat it. Then it might make more sense for me to do that. So that's one of the uses of history. History is also very useful for when you've done a whole bunch of commands and you want to go back and see, like, well, what was the thing that I did before? And you might want to circle back through and see what that thing is. Try to find all the files all in that directory that start with a C, all of them that contain an A, all of them that end with an O, and then I want you to find the line number in your history that will allow you to exercise just the listing of files in bin and reissue that command. And if you get a chance, there's a nice little bonus question here. Can you actually list all the files in bin that contain the letters A or C? A or C. You might have to do a little bit of looking around to figure that out. But this will be a good exercise. One of the things that can be very helpful in learning how to program is to use the internet as a resource tool. And so I haven't actually told you exactly how to do that. I have hinted at it. And there are some things that might be similar to it, but I haven't showed you explicitly how to do it. So see if you can poke around and figure that out. A little bonus exercise, but it's worth seeing how well and starting to familiarize yourself with how to search for a way to solve a problem that you may not have seen explicitly addressed in class. So in addition to these exercises, I'd like to try around. I want to show you a couple other things. One of the big things here that I wanted us to start thinking about is how to create and join files. So in Unix shell, right there, when you have commands, they can often take in information, and we refer to this as standard input. So this is information that goes into a program. We also have information that comes out of a program. We call this standard output, and usually that's the stuff you see printed to the screen. There is also, you'll sometimes get error messages, and these are, they write also to the screen, and they're called standard error. Now, there's a difference here, is that standard output, there are actually two channels of output. There's channel 1 and channel 2. Standard output always goes to channel 1, standard error goes to channel 2. So if you want to, you can isolate these things out differently from each other. But for all our intents and purposes, we're just going to refer to anything that gets printed out right now as standard output. So standard input comes from the keyboard, standard output and error go to the terminal screen. One of the things that Unix is, a really powerful feature of Unix, is you're able to move data on a stream. So that means I can use the greater than, the less than, the double greater than, the double less than, and the bar to move data around. So let's see what I mean by that. So we're going to use a command common in Unix called cat. And what does cat do? So if I use I'm going to move back to my media, SFS, data, shell genomics, my seq directory. Right now I have all my sequencing files here. What does cat do? So if I take a file and I want to see what's in it, cat prints all of the contents of that file to the screen, the whole file contents. If I wanted to see how many lines are in that file, I could use a command called WC, which stands for word count. And if it's WC-L, that word count will then stand for word count -lines. So it's going to count how many lines are in that file. So if I look and see how many lines are in that file, you can see that there's about 30,000 lines in that file. This is a FASTQ file. I don't know if you remember, but before we talked about FASTQ, FASTA files. So if I was going to think about, how many sequences are in the sequence, I could take 31,172 and divide it by 4, and that tells me that there's 7,793 sequences in this file. So, but most importantly for me, there's about 31,000 lines. And notice, like when I use cat, one of the powerful things about Unix is like it goes pretty fast. It goes through 31,000 lines in just a few seconds. If I wanted to look a little bit more closely at this file, we could use the program less, which I've talked about before in one of the videos. And less would allow us to navigate around a little bit. So here, once I log into less, I can use the space bar or the down arrow to move down. I can use the B button or the up arrow to move back. I can use I can hit lowercase g and it'll take me to the beginning of the file. If I use capital G, so Shift G, it'll take me to the end of the file. And if I want to get out, I can just hit the Q button to get out. Less generally works this way. You just say less space, the name of the file, and it'll open that file. It's a text viewer. And I can also open it and I can use line numbers. So say I wanted to use, I wanted to have some idea of what number or line I'm looking at. Here you can see how the FASTQ file works, right? The first is a sequence identifier. The next is a sequence, then a plus sign, then another sequence, then a sequence identifier, then a sequence, then a plus sign, then another sequence, right? This is that 4-line format that we talked about. If we go all the way to the end of the file with a capital G, we can see that there are 31,172 lines, just like I showed you earlier with the WC-L command. If I just wanted to look at the beginning of this file, I can use a command called head, and this will print out just the first 10 lines of the file. So here I can look at just the first 10 lines, so just the very short parts. This is helpful for just kind of peeking into a file if you want to see how it works. In addition to this, in addition to head, there is also tail, and this will show me the last 10 lines of the file. So if I wanted to just see real quick what the end of the file looks like, I can look at it like this. If you just want to take a quick peek and not sort of cycle through the whole file, you don't have to use the cat command. So for these redirection commands, I'm going to show you something using the examples dataset. So in the examples dataset, now I've gone back out of shell genomics and into the examples dataset. You'll notice that instead of FASTQ and FASTA files, there's a couple text files, and there are these .seq files. These .seq files are actually, if we were to look at one, they are actually FASTA files. People historically have used lots of ways to refer to these files, but that's what it looks like. It's a file with 2 lines, where the first line is the sequence identifier and the second line is the sequence. So if I wanted to look at all of the seq files, I could simply print them to the screen and say, hey, I want to print all of the seq files to the screen to look at them. And so I can hit I can say cat and use that asterisk.seq, that wildcard.seq, to print the results of all the seq files to the screen. So here I've looked at the contents of all of the seq files and printed them all to the screen. Now maybe I actually wanted to just look at the long list of like when these seq files were created. So I could say, hey, list out all the information about these seq files. And I could say, oh look, there it is. I listed out this information, for each of these seq files. Remember, I'm using that wildcard to only look at some of these files. Now say I wanted to take this information and I wanted to save it. I wanted to put it into a file. Well, so this is information that got printed to the screen. To put it into a file, I can redirect it using the greater than sign, or this caret, and I can funnel it into a file called files.txt. So if I hit this, notice that nothing gets printed to the screen. But now what's happened is that that information is now stored within the files.txt. So I've created a file with very little effort using the operator, the greater than operator sign. So this redirection is really important. So say I wanted to take all the contents of these sequencing files, right? And I wanted to put it into one file. I didn't want to have them all in different files. I could put it into a file called ketignath.fasta. And normally if I had done this, I would print everything to the screen. Now, when I do it, everything goes into the file. And if I was to look at that file, right, it would have all of that information. Additionally, I could just redirect a subset of what I was interested in. So say I was only interested in sequences that ended in sequence files that ended in a 1, right? I could do that and say, hey, I'm going to put it in a different file called subset.fasta. And now if I look, I've created not only the ketignath.fasta file, but also the ketignath.subset file. And in it, I should have this file, 1, 2, 3, 4, 5, 6, 7 sequences. I could do let's say I wanted to add the number 2 file, this file, and this file to the end of these sequences. So if I look at that ketignath subset file, right, I've got all the 1 sequences that end in 1, but then I want to add the ones that end in 2 to the end of it. I can use the wildcard 2.seek to output the results of those files. But if I want to add it to the end of the file, I can join it to the end of the file. I can concatenate it to the end of the file using the double greater sign. So the single greater sign will always create a file, and if I give it the name of an existing file, it'll just overwrite it. And there's no protection here, no warning. It's Unix. Once you hit return, it's going to happen. But in this case, if I use the double greater than sign, it's going to add it to the end of the file that I was looking at. So here we can note that this is the 01A09 file, right? And then if I open up that ketignath subset file and I go to the end, it is this 01A09 file that now is at the end of this file. The last redirect that I'll show you guys is the bar. And what the bar does is it allows us to redirect the output from one command to be the input for another command. So in this case, I could say I just wanted to print out the beginning of a sequence. Let's go back to a longer file. So I'm going to go back to that MySeq, the Shell Genomics MySeq data file using the relative path. And I'm just going to look at one of these files since they're kind of long. Let's just look at the first sequence or the first 2 sequences for a file. So here, we're just going to look at the first 2 sequences. So if I say head-n4, instead of the first 10 lines, which it does by default, it'll only output the first 8 lines. So doing that, we can see that, okay, I got sequence 1, I've got sequence 2. All right. The next thing I want to do is I want to just output just this second sequence. So I want to put out the end of this output. So that output, I can send it as an input to my tail command. Remember, tail is just like head. By default, it'll put out 10 lines. But if I say instead to only put out 4 lines, what we can see here is that before I put out that head command, put out the information for 2 sequences. But when I tell it to take that output, right, pass it on to this command, it's only going to put out information on the last sequence. And that's what happens here. Notice that this is identical information. So what I can do, it's really interesting, is I can use these operators like the greater than and less than signs and the bar to redirect information in the UNIX interface. And that's our little lesson on additional UNIX operators.